to EC Electronics. This is a video on tips and tricks to solve network analysis problems. So if you're going for some competitive exams related to electronics, you need to really do the questions very fastly, mostly by mind calculations, so that you can complete all questions within a given time. Okay, so the time is very important when going for some competitive exam. And just like your aptitude or reasoning questions, the electronic questions should be also should be done or solved very fast. Okay, so in this video, we are going to see some tricks and tips to solve the questions from network analysis subject. Okay, so the first concept we are going to study is the per ohm voltage. This is the per ohm voltage, which states that if two resistances are connected like this, say the values be R1 and R2, and the voltage between these two resistors be V. Okay, so we have given the voltage across this R2 be V2. Then the per ohm voltage for R2. That is, this R2 is some resistance. And for a particular, that is 1 ohm of R2, the voltage is called per ohm voltage. So the per ohm voltage is per ohm voltage for R2 is given by V2, which is a total voltage, by the value of the R2, which is a resistance. So this will be the per ohm voltage for your R2. Now, if these two resistors are connected in series, then the voltage across R1 will be, R1's voltage is per ohm voltage into per ohm voltage into the value of resistance, which is R1. So for this case, here the per ohm voltage is V2 by R2. So V2 by R2 into R1 will be the total voltage across the R1. That is, here it is V2 by R2 into R1 will be the voltage. So how we have calculated this voltage? This voltage is calculated by first calculating the per ohm voltage, then multiplying it with its resistance value. Here the per ohm voltage is V2 by R2, because we have given that the voltage across R2 is V2. So V2 by R2 into R1 will be the voltage across the resistance R1. Okay, so this concept is actually called the per ohm voltage concept. And now we are going to do a complex question with the help of this concept, which is a per ohm voltage concept. The question which we are going to discuss is this. So this is a circuit given and we need to find the voltage in between these two terminals A and B. That is, V is the voltage and we need to find the value of V. So how can we apply the per ohm voltage concept here? Let us see. So here 10 ohm resistor is given and the voltage across this 10 ohm is given as 50 volt. Okay, so what is the per ohm voltage for that 10 ohm? Let us try to find it out first. So the total voltage is 50 and the total resistance is 10. So the per ohm voltage is equal to 50 by 10, which is equal to 5 volt. Okay, so this 10 ohm is having a 5 volt of per ohm voltage. Now, if you see these two resistors, they are connected in parallel connection. Okay, so this 20 and 20 are identical and they are in parallel connection. So the equivalent resistance will be 20 by 2. Okay, 20 by 2 will be the equivalent resistance for this combination. So it will be equal to 20 by 2 is 10. So we can replace it with the single 10 ohm resistance. Okay. Here again, as I said earlier, if it is this 10 ohm is having a per ohm voltage of 5 volt, then what is the voltage across this 10 ohm? It will be 10 into the per ohm voltage, which is 5. So the voltage is 50 volt is present across this 10 ohm resistance. Okay. So now we have two resistors with 10 ohm and 10 ohm, with one having 50 volt and another also having 50 volt. So the total resistance is 10 plus 10 is 20 and the total voltage is 50 plus 50 is 100 volt. So we can replace this 10 and 10 with they are connected in series connection. So the total resistance is 10 plus 10, which is equal to 20 ohm. So we can replace this with a 20 ohm resistance of total voltage is equal to 100 volt. Okay, fine. So we have simplified till this. Now there is a 20 ohm, there is a 5 ohm. So if you take this two, they are connected in parallel connection. So the equivalent resistance is 20 into 5 by 20 plus 5. So just applying the series and parallel rules and applying the per ohm voltage concept. So here it will be 20 into 5 is 100, 100 by 25, which is equal to 4 ohm, is the equivalent of this 5 ohm and 20 ohm. So I am going to replace it with a single 4 ohm resistance value, and the voltage will be same. So there is a single 4 ohm resistance with a 100 volt across it, right? Okay, so what will be the per ohm voltage again for this 4 ohm? So the per ohm voltage will be, voltage is equal to 100 by 4, which is equal to 25 volt. Okay, so the per ohm voltage for 4 ohm resistance is 25. Now what is the value of resistance for, what is the value of voltage across this 1 ohm? It will be equal to, the value of resistance is 1 into the per ohm voltage is 25 now. So 1 into 25, here the voltage is 25 and here the voltage is 100. So what is the total voltage? It is equal to 100 plus 25, which is equal to 100 plus 25 equal to 125. So this is the answer for your B. So this is how we can find the value of voltage across any combination of resistance using the per ohm voltage concept. Okay, so how can we apply it? We can find the value of per ohm voltage for any resistance and then apply this per ohm voltage to find the voltage across other resistors. Okay, so here also if you see, the total voltage is 100. It is a 4 ohm resistance. So the per ohm voltage is 100 by 4, which is equal to 25. And this 25 is used to find the voltage across this 1 ohm resistance, which is equal to 1 into 25. So it is 25. So the total voltage is 100 plus 25 equal to 125. Okay, so I hope this concept is clear. So this is a new concept we are going to apply in the competitive exam, simplification of the network analysis questions. We need to find the current value through this 6 ohm resistance. So how will we normally find this value? That is, how can we normally solve this? By either applying the nodal analysis for this node or applying of KVL, Kirchhoff voltage law, or Kirchhoff current law, we can do it, right? So how can we simply do such questions? So we can apply the superposition theorem in order to simplify these questions very faster. How? We'll see. So in this question, if you see this circuit, there are two sources. There is a current source, there is a voltage source. So how the superposition theorem is done? We'll only keep one source and we'll remove the other source and keep that terminal as an open terminal. So likewise, you can find the current through this 6 ohm resistance. So the current is actually contributed by both the sources, this current source and this voltage source. So we'll find the current contributed by each sources independently and then we will add. So that is a very simple method. Okay, let us try to do it. First I am going to remove this current source, which is having a 2 ampere. Okay, so the current source is 2 ampere. Now this terminal is open and I am going to find the current caused by this 6 volt voltage source. Okay, so what will be the current? There is a voltage, there are two resistors connected in series. So the current I will be equal to I1. I will try to call because it is only a one portion. The next portion we need to find. So I1 will be equal to voltage 6 by the resistance is 3 plus 6 is equal to 6 by 9, or it is equal to 2 by 3. It is 2 by 3 ampere we will get. Okay, or 6 by 9 we can write. Okay, now that is the one portion of the current. Now we will keep the current source as it is and we will remove this voltage source. So this current source is having a value of 2 ampere and we are going to remove this 6 volt voltage source and keeping this terminal as open. Okay, now there is a current source here. There is a current contributed by this current source. Okay, and we need to find this current source or the current value. Okay, how can we find it? We can apply the current division rule here. So it is a 2 ampere being divided between this 3 ohm and 6 ohm, right? So I2 is the current contributed by this current source of 2 ampere. So according to the current division rule, the 2 ampere is divided between 3 ohm and 6 ohm. So 2 into the opposite resistance value is 3 by 3 plus 6. So it is 2 into 3, which is again 6 by 9. So it is a 6 by 9 and 6 by 9. So the total is, so this is again 2 by 3. Okay, so it is 2 by 3 plus 2 by 3, which is equal to 4 by 3 ampere is a value of the current I. So this is how we can simply find the value of current through the 6 ohm resistance. So there is again a voltage source of 6 volt. Okay, so we have not applied any nodal analysis or mesh rule or anything. We have simply taken the superposition theorem to solve this question. That is by keeping only one source and keeping the other terminals open, and again doing it for the next one. So thus by finding the current contributed by the two sources, we can find the total current value. So the question is, we need to find the value of I. So the I is the current flowing through this 4 ohm resistance, and we need to find the value of this I. So how can we normally do this problem? So there are 4 loops here, and we will be applying the either KVL or Kirchhoff current law to solve this to find the current value, or by applying of nodal analysis, right? So that is a very lengthy process. How can we solve it in a quick manner? So let us see for some loops in the network. So if you see this branch is not having any element. It is actually a short circuited or a bypassed section or a branch, which will make this circuit as two separate circuits. Okay, so if you see this circuit, this will be acting as a single or an independent circuit. The rest of the circuit will be acting as an independent circuit due to this short circuited or a bypassed branch. Okay, so we can actually draw two separate circuits, one with this 6 ampere and another with the 6 volt voltage source. Okay, so I'll draw separate circuits for this. There is 2 ohm is here, there is a 4 ohm resistance, and this will be a separate circuit, and this 6 volt voltage source and resistance will be acting as a separate circuit. So we have obtained two circuits from this bypass branch. Okay, so we actually need to find the value of current through this 4 ohm resistance, right? So how can we find it? Simply, if you see here, so this is a 4 ohm resistance, we need to find the value of current, right? So how can we do it? So there is a 6 ampere current, and it is being split across this 4 ohm and 2 ohm, right? So we can apply the current division rule, and we can simply find the value of current I. Rather than going for simplifying all this network, all this circuit, we can by using this short circuit concept, we can solve this question very easily. Okay, so I'm going to find the value of current here. So this 6 ampere into, how the current division is applied here, there is an opposite resistance, and we need to find the value of current through this 4 ohm. So 6 ampere into the value of opposite resistance is 2 by the total resistance is 4 plus 2. That is your I4, right? So 6 into 2 is 12. 12 by 4 plus 2 is 6. So that is equal to 2 ampere is the value of your I4. So this is your I4, or I is equal to I4 is equal to 2 ampere is a value of current. Okay, so this is another concept which we can use for the solving of networks. Okay, so that is a short circuit concept or the bypassing of circuit concept. So these are some tricks which you can apply to solve your network analysis subject questions fastly in the competitive exams. Okay, we'll be seeing in the next video with more tricks and also subject related videos. Okay, so if you want to see more videos, please do subscribe to the channel. Thank you.